Orbital phases determine whether atomic orbitals combine to increase electron density between atoms and form bonds, or cancel each other and prevent bonding, with same phases reinforcing bonding and opposite phases causing cancellation. Think of orbitals like waves on a pond, where the top of a wave is one phase and the bottom is the opposite phase. When two waves meet with their tops together, they add up and make a bigger wave between the two atoms, which is where bonding electrons like to sit. And when a top meets a bottom, they cancel and leave a node with no electron density. So bonding is not favored. For simple examples, when two s orbitals or two p orbitals with the same phase overlap head-on, they make a bonding combination with increased electron density between nuclei. And when their phases are opposite, they form an antibonding combination with a node in higher energy. For p orbitals, side by side with matching phases, you can get a pi bond with increased electron density above and below the bond axis. But if the phases are opposite along that contact region, the overlap cancels and you get an antibonding pi orbital. Visualizing the sign of the orbital lobes and where the electron density ends up makes it easier to predict whether a given overlap will stabilize or destabilize the molecule. Students often assume any overlap automatically makes a bond without checking phase, and that leads to wrong predictions about bond strength and symmetry. Always check whether the lobes that meet have the same sign. Another common mistake is ignoring nodes in antibonding combinations and thinking they still contribute to bonding. Remember that nodes mean zero electron density between atoms, and therefore no stabilizing bond. A final misconception is treating all overlaps as equal in size. Even if phases match, the geometry and orientation control how much overlap occurs. So consider both sign and spatial alignment when judging bond formation. For more videos and resources that explain orbital phase, bonding, and visual examples, visit www.gumballdegree.com.